Yo, what's up, guys? Welcome back. Um, yeah, episode 73 gonna be a little bit of a quick episode. I'm actually gonna get food with my friend, and a couple of my friends are coming in town, so probably not gonna be a very long video, but we're gonna do a couple problems because I definitely just wanted to. I also got a haircut. If I wasn't getting a haircut, then I would be recording this video, but yeah, my hair looks kind of short, but okay. Anyway, yeah, let's take a look at the Pokemon of the day. So I think, yeah, episode 73, so Pokemon 73. We got the evolution of Tentacool, which is Tentacruel. Let's take a look at the sound. Beep. Beep. Let's hear it again. Beep. 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 Does that sound? Imposter syndrome. Let's go. Okay. Let's take a look at some problems. What we're gonna do, I think, just because I have about, I don't know, maybe half an hour or something. So what I'm gonna do is maybe more, 45 minutes, I think. I have no idea, actually. Maybe we might record an hour. I don't know, but okay. We're gonna race through some of these linked list problems in Leetcode 75, just because I think I should be able to do them. I think, hopefully. Take that with a grain of salt. Maybe I'll have some trouble. I don't know, but yeah, we have to do this asteroid collision one too. We'll do this one. Delete the middle node of a linked list. We'll take a look at this. You're gonna have a linked list. We want to delete the middle node and return the head of the modified linked list. The middle node of the linked list is size n2 from the starting user zero base index, where x denotes the largest integer less than or equal to 0. Okay. Okay. So I believe this is a fast and slow pointer. So what we're gonna do is we're gonna create a pointer cur, which is equal to head. We're gonna return the head though. And do while cur does not equal none. We're going to okay, we need to create our slow pointer. Slow and fast, right? Ooh, but hang on, how are we gonna delete this linked list? Are we actually deleting the value, or are we gonna have to rearrange them? That's the thing. I don't know. Okay, let's just do our fast and slow pointer, right? So while cur does not equal null, we'll do slow is equal to slow.next, and fast is equal to fast.next.next, right? So this should get us to our midpoint. So our slow should be at our midpoint. Then we'll create a previous pointer, previous equal to head, and we'll loop through while prev does not equal none. Prev is equal, sorry, while does not equal while prev.next, hang on, would this work? While prev.next does not equal slow, we'll loop through and do prev is equal to prev.next. I'm curious. Let's print our prev.val, and we'll print our slow.val. Slow.val. Take a look where we're at here. Of fast does not equal null. Null or fast dot next does not equal null. None. I think we gotta do both. There's no attribute next, fast equal to fast. Okay. I am so hungry, bro. Bro. Getting attribute error, null attribute error. Okay. Let's think about this. Why are we getting an attribute error here? Why are we getting null pointer error? Okay, while fast is not none and fast on next is not none. Oh, it should be an and. Why an and? Okay. Why? Because this one's leading to a pointer. Okay, so we got. Okay, we're printing 4 and we're printing 7 here, right? We're printing 3 and 2, okay. And we're printing, okay, 1 and 2. Okay, that's good. Okay, so what we want to do is we want to get our previous, right? So what we want to do is we want to swap our links. So we want to make, well, swap our links. We want to make so prev.next is equal to slow.next. Wait, no, sorry. Okay, maybe this will work. I don't know. And then we just return our head. I'm curious if this works. I am actually not sure. I wonder if okay. None type has no attribute next. Okay, maybe instead of this, right, we can do prev is equal to none, right? But we can create a new node. We can do, well, prev.next is equal to slow. And then we can increase prev.next. Sorry, prev. We can do prev is equal to prev.next. Maybe this would be the better way to do it. And type has no attribute next. Why are we getting that? There's no attribute next. Can we make it equal to head? I actually don't know why I'm getting a null type error here. Why am I getting a null type error? You're getting no error on this line. Previous initialize is none, then you try to actually. Let's cause a note previous equal to head. This avoids accessing the dot next on none. That's smart. Okay. So instead of doing it here, we make prev equal to slow, because then slow is increasing every time we're taking access to the previous node. Okay. I can prev equal to head now. Okay, now we need to get rid of that too. Okay. Will this submit now? I don't know. We're getting a null type error prev.next equal to slow.next. Okay. If prev is not none, then maybe that should fix it. Okay. Expected. Why are we passing all these test cases but not this one? I think this is our edge case when we have one value, because technically we don't have a prev, so. Not sure. Why am I not passing all edge cases? A single node, yeah, that's the one. If there was only one node. Okay. If head is none, or head.next is none, we just return none. That should clear up our edge cases, I think, potentially. Okay. Wow, that is the slowest solution. Okay. What is the fastest, dude? The same fucking solution, pretty much. Okay, so it's a previous none. Okay, interesting. Okay, well, there's our first one done. That's cool, man. That's cool. That's cool. That's cool. Let's do an odd even linked list. Given the head of a single linked list, group all the nodes with odd indices together, followed by the nodes with even indices, and then return the reordered list. Shit, that's hard, bro. This is a tough problem. 61% acceptance rate. Key must solve this problem O of on extra space and O of n time complexity. Okay. I think it's probably more going to be kind of like a two-pointer solution, I'm thinking, is my intuition. So I'm thinking we start from here and we go 2, 3, 4. Oh, one extra space. I mean, you could easily do this using a different data structure, but we want to solve it in place. You know, that's really tough, man. first node is considered odd and the second is even, and so on. Now that the relative order inside both even and odd groups should remain as it was in the input. I don't understand this test case here though, because we have a even, odd, odd, even, odd, odd, even. So how is that sorted? Am I missing something here? Oh my gosh. Okay, we're going odd, even, odd, even, odd, even. Okay, I understand. So 2, we go odd. Okay. I thought it was even and odd, but alright. Maybe we could sort the evens first, and then we can do the odds. I don't know. Yeah, honestly, I'm not sure about this one. This is a tough one. I'm definitely going to need a clue here because I'm not sure. How can we solve 328 odd, even, linked list? Give me some hints. This is a tough problem. I'm going to take a look at the discussion. Okay, I was right. We do have to maintain 2 pointers. So use 2 pointers, odd and even, maintain 2 pointers. Odd starts at the head, first node. Even starts at head.next, second node. Keep track of even head, which stores the head of the even sublist. Iterate through the list, moving odd to odd.next, and even to even.next to separate the 2 lists. Once the loop ends, connect the last node odd to even head, which is the head of the even list. I'm kind of confused now. Hang on. I'm kind of confused what's going on here. Am I... Okay. Screw this. I'm just going to create 2 pointers. So we're going to make even is equal to head, right? Then we'll make odd is equal to head, right? And we'll loop while equal to head.next, and we'll make the even underscore head, which is equal to head.next, right? Okay. Okay, while even does not equal to none, and even dot next does not equal to none. Right? I think or odd does not equal none, and odd dot next does not equal none. We loop and we do well. Are we creating? Okay. I think we only need this, to be honest. Okay, so I think here what we're doing is that we're connecting the iterate through the list, moving odd to odd dot next on x and even to even dot next on x. So we move odd is equal to odd dot next, moving twice, and we do even is equal to even dot next. Then what we need to do is once the loop ends, we connect the last node odd to even ahead. Okay, so odd dot next is equal to even underscore head. You know, edge cases, so I guess if head is none, we return, what are we looking for? None. If head if head and head dot next, we just head dot next is equal to none. Sorry, is none. Right? We return head, right? So I guess if it's no greater than 2 values, right? I think that's the way we want to do it. That is the way to do it, if not head. We return head. Okay. Here it says odd dot next is equal to even dot next, and then we increment odd is equal to odd dot next. Even dot next is equal to odd dot next. We increase even is equal to even dot next. Do that, and then we return our head. event again, dude. Jeez. Why are we getting event.next? Wow. This was a poorly written problem. If not, hit that next and next. Okay. Let's just get rid of this and see if we even need this, to be honest. There we go. Wow, didn't even need that. It's such an interesting problem because the description is so bad. Like this, I don't know. Pretty much what we're doing is we're looping through this, right? And we're checking, well, since our first node is considered odd, we make odd is equal to head, and we make our even is equal to head.next, right? So then we make odd is equal to odd.next. I'm confused here. I think we should have odd.next and x and even.next and x. Figure this out. I'm just trying to confirm why it's even.next and not even.next and next. Can you show me with this test case? Odd stores 2 so we can reconnect later. That's interesting. Okay. Let's do it on Paint. Let's do 1, 2, 3, 4, 5. Okay. We loop through this and we check, well, okay, so our odd starts here, right? So our odd pointer is here. Our even pointer is here. And then our even underscore head is over here. Alright. So as we loop through in our first iteration, we have odd.next is equal to even.next. So odd.next, which is this link here, is equal to even.next. So instead of this here, actually we're going to go iteration by iteration. We're going to do different colors, right? So let's do, instead of this here, we're going here, right? Then we want to do, well, odd is equal to odd.next. Okay, so we move this odd, we make this is odd, right? Then we want to make even.next is equal to odd.next. So even.next is equal to odd.next. So 2 is 4, right? Even.next is equal to odd.next. Even is equal to even.next. So then this moves out even here. Okay. We'll do yellow. I'll do oranges. And no, we'll do yellow. Okay, so then we go to our next loop. So while even does not equal null, even does not equal null, and even.next does not equal null. So we're good. Alright, so we go to our next loop, right? So we started out odd. We do odd.next equal to even.next. So odd.next equal to even.next. So we remove this link. We move this here, right? And then we move odd, right? Sorry, we need to get rid of this even here. Let's get rid of this. And we move odd to here, right? Okay. Even.next is equal to odd.next. So even.next is equal to odd.next. So get rid of this link. 4 goes to null, right? There's like a null pointer here, right? So this is, and then we make this equal to even, right? And we remove this, right? So technically what we return here is we return 1. Let's fix up all our links, right? So we'll make this lime green, right? So we have 1, 1, 3, 1, 3, 3, 5, 1, 3, 5, and then we make odd.next is equal to even head. So we're at odd.next, so then we fix this link here. We make this equal to even head, right? So this goes all the way over here. And instead, now we have 2 here, and we have 4. 1, 3, 2, 4. Wow. Okay. Interesting problem. Interesting problem. Yeah, wow, that's an interesting solution. It's a good solution, though. So pretty much what we're doing is we're making the odds and then the evens. I think the description is poor. I think it's wrong here, bro. Like, honestly, like, but I don't think it'd be here so long if it was. I mean, there's 1.9 million solutions. They do the same way. Interesting. Okay. Submit it one more time. Alright, we'll jump through to another problem. Let's take a break from a linked list problem. I kind of want to jump to something else. Let's go back to our old problem from yesterday. Now, asteroid collision problem. Let's reset this. Okay. Now, I didn't read this properly yesterday because I was kind of in a rush. I had to go to the bathroom. Okay. Let's take a look. So for each asteroid, the absolute value represents size. Asteroids in a row, the indices of the asteroid in the array represent their relative position in space. For each asteroid, the absolute value represents its size, and the sign represents its direction, positive meaning right, negative meaning left. Each asteroid moves at the same speed. Find out the state of all the asteroids after all the collisions. If two asteroids meet, the smaller one will explode. If both are the same, both will explode. Two asteroids moving in the same direction will never meet. Okay. So obviously we want to create a stack, right? We want to loop through our values in here. So we want to do for I in asteroids. Okay. We want to check, well, while our stack has something in it, right? While stack and we can check if I is alright, so we're gonna check while I is, we put in a positive number, we're gonna check while I is greater than 0 and the top of the stack is greater is less than 0. Maybe we can check the absolute value here too. I'm thinking maybe we could check the absolute value of both, right? And if 10 is greater than 5. Let's try that first, okay? Let's check, well, if the absolute value of I, okay, let's check the absolute value of stack minus 1 is greater than the absolute value of I, right? So we need to do something to this, right? Okay, and sorry, no, it should be, it's less than this, right? So if it's less than this, if stack minus 1 is okay, so we know one of them is bigger, right? But if they're the same, we don't do anything, right? If stack minus 1 is greater than 0, and abs and I is greater than 0, then we append, right? Stack.append I. We would append in this case, right? If they're both greater than 0. It's greater than 0, I append to the stack. They're going the same way, right? The same way. Also, if stack -1. No, I think it's better that we check direction first. I think we have to check direction. If stack -1 is greater than 0, and while stack and stack -1 is greater than 0, and I is less than 0, then we check, well, if abs stack -1 if it's greater than if abs stack -1 is greater than the absolute value of I, so if I is greater, we just continue, right? Else if abs stack -1 is equal to abs I, if they're the same, right? It says here, if both are the same size, both will explode. So then both of them explode, right? So stack.pop. We skip over this one. We just stack.pop. Else, if it's less than, then we have to pop from our stack. Otherwise, we add our value, right? So we do stack.append I. Let's do value here, because I feel like I is a little bit confusing to kind of think about. It's better we call it value. Value. And then obviously we would return our stack. Let's see what it gives us. Oh, it's because this is in the while loop. Okay, infinite while. Nice. Okay. Full value in asteroids. While the stack is on empty and stack -1 is greater than 0. Think about this logic, right? The first thing we're going to append the value, right? So we're going to append 5. Then we're going to go to 10. And we're going to be comparing 10 to 5. Well, if 5 is greater than 0, which it is, and value, and we just append, right? This is not true, so we just append. Then we go to a -5, and we check, well, is negative greater than 0? That's what's messing up here. Negative greater than 0, it's not. And value. Maybe we switch these signs around. Stack, well, the top of the stack is less than 0, so we get a negative value. And value is greater than 0. But this doesn't print anything. This is just an infinite while. Oh my god, dude. Something wrong with this while loop here, but I'm not sure. Let's take a look. What is wrong with this while? I don't know what it would be, man. I just don't know. If abs is greater than... Okay, break. Stack dot pop. Break. Then we have an else. Else. We append. Does that really fix it? Wow. Okay, we will close though. So we were right here. This one is greater than 1. Value is less than 0. Okay, show me a test case. Okay. 10, negative 10, pressing negative 10. It's positive, negative collision occurs. That's interesting, right? I've said why this one is greater. Oh, yeah. we break, right? We don't add anything. Okay. As is greater than as the value, right? Then there's no point of doing anything, right? Because we just want to skip over this value. So we break and go to the next value of the for loop, right? Else if ab stack -1 is equal to that value, we stack dot pop and then we break because we can skip that value in the for loop as well. Else, if okay, then we go to else if the value in the for loop, if value is greater than stack -1, then we pop and we go to the next value in the while loop, we check the same thing. So we would pop all those values. Other than that, if there's nothing in it, then we append to our stack. Okay, I understand. Interesting problem, interesting problem. I can't believe we've already been doing this for an hour, dude. Nearly. Crazy. Man, time flies, bro. Okay, let's submit that. Let's take a look at what was this one again? We did this a couple days ago. I'm just curious. Right, some. So it's easy to get the right sum. We have to do the total sum minus sums. Interesting. Okay. Yeah. Okay. Yeah, let's just take a look at this one. This linked list problem. In a linked list of size n where n is even, the ith node zero index of the linked list is null as the twin of the n minus 1 negative 1 node. If 0 is less than I is less than n over 2 minus 1. For example, if n is equal to 4, the node 0 is a twin of node 3, and node 1 is a twin of node 2. These are the only nodes of twins of for n is equal to 4. The twin sum is defined as the sum of a node and its twin. Given the head of a linked list with even length, return the maximum twin sum of the linked list. What a stupid problem. Okay, I'm trying to think here. This will probably be our last problem today. Okay. I'm thinking what we do is we get a pointer. We loop all the way to the end of this array. We get this pointer. Oh, shit, we're not in an array, so we can't go the other way, right? You could also turn this into an array, too. I'm trying to think how we can do this without an array. The thing is, we won't be able to loop back. That's the issue. You know, like we get to the end of the array, but we won't be able to loop back. But do we get the size of the list? No. Can we somehow like calculate the end of the list? I'm going to solve it my way, right? Because I'm not sure how we can do this just with a linked list, right? So I'm going to solve this my way, as if kind of I was in an interview. This is the way I'd solve it. It probably isn't the right way to solve it. I mean, it definitely isn't the right way to solve it, but I think I have an idea on how I can solve it. So what I'm going to do is I'm going to create a cur, right? I'm going to simply just loop through this while cur does not equal none, right? I'm going to add the cur value. So I'm going to add, well, I'm going to set up an array, right? Array is equal to this. Then I'm going to loop, well, array dot append cur.val. Cur is equal to cur.next, right? Let's print our array here. Five, four, two, one. Okay, right? So what we're gonna do is we're gonna get our last value in array. Alright, so we'll do last is equal to the length of the array minus 1, indexing the last element in our array 1, right? And what we're going to do is we're going to loop through while cur does not equal none. We're going to create our first pointer. First is equal to head. We're going to loop through and check max, right? We're going to create our res integer here. We're going to loop through with our first. Then we're going to check, well, while first does not equal none. We're going to check, well, first dot val plus length of the array plus, okay, nums last. Let's do ands is equal to first, right? Then we're going to check the max. We're going to check, well, max. We're going to check res is equal to max res and then we'll loop through our array again. So we'll do, well, first is equal to first on next, and then last minus or equal to 1. And then we'll return our res. I believe this should work. Oh. This is array. Okay, that's what I thought. it passed. We did it. But that definitely wasn't the right way to do it. Let's post a solution. Linked list, create array, and then loop through linked lists again, and compare from back of array. Let's do end of array. Time complexity here, resolve n. Now space is all in. Let's post that solution. Okay, let's take a look at how we can solve this without using an array and cheating. 2130 maximum twin sum of a linked list. How can I solve this in O of 1 space? Let's take a look. Use slow and fast pointer technique to find the middle of the linked list. Once the middle is found, you can split the linked list into 2 halves. Reverse the second half of the linked list. This allows you to easily compare from the front of the list and the rear of the list without extra space. Calculate the twin sums. Now compare the nodes from front and the rear of the list, the reverse second half. Keep track of the min twin sum if required, for example, if you need to. Interesting. This kind of adds kind of everything together. So we're going to do this. That's actually, I would have never thought about that, but that's cool. So the first step is what we want to do is we want to find the middle of our linked list, right? So to find the middle of our linked list, we can use our fast and slow pointer technique, where we can create a slow pointer here. Why can't I click enter anymore, dude? What? I don't know what is going on here. Okay. All right, we can create our head. We do while fast does not equal none. My friend is on his way. Hopefully we can finish this. While fast does not equal none, fast on next does not equal none. Then we can make fast is equal to fast on next on next. Sorry, whoops. Slow is equal to slow dot next. Fast is equal to fast on next, right? Then find mid. Reverse second half, right? So when we reverse the second half, we want to make, well, actually, we probably want to make a prev, right? So let's create our previous is equal to none. We loop through here. And we do prev is equal to slow, right? So then we can do, well, we reverse here with the previous node. We can do, while slow does not equal none, we can do, let's do next is equal to slow dot next. This kind of adds all my knowledge about linked lists into one problem. That's kind of crazy. What a good problem this is. Next is equal. I didn't think about putting them all together, but it's cool to kind of do it. So we make our next point, all right, and then we want to do, well, we want to fix that link. So we want to cut the link. So slow.next is equal to prev. And then we want to make, well, prev is equal to slow. and slow is equal to next, right? Okay, we reversed it. Okay, but we probably want to keep a pointer. Let's make slow 2 is equal to slow, right? Because then eventually now we're going to have to calculate the maximum twin sum, and we're going to have to loop through again, right? So calculate max twin sum, right? So what we want to do here is, so now we got 5, 4, 1, 2. I guess we want to loop through. So while slow 2 does not equal none, we want to check, well, do our and is equal to code 2 is equal to head. We can do, well, code 2 dot val plus slow 2 dot val. Then we can do our max function. We do max is equal to res. We need to create a res over here. Res is equal to 0. Max is equal to, sorry, res is equal to max, res, ands. Yeah, and then I believe we can just return our res here. Let's see if this passes. Kind of interesting. I didn't make any mistakes there. Kind of impressive. Doesn't look like it. I think we have made a mistake somewhere. Oh, we're not incrementing here. That's why. Slow 2 is equal to slow 2 dot next. And then we need to do code 2 is equal to code 2 dot next. Yay. I don't know why I'm getting a null pointer here right now. Why are we getting a null pointer? Maybe if head, if not head, turn 0, right? Could that be it? I don't know why. Why am I getting a null pointer here? Am I getting a null pointer attribute error? Line slow 2 is equal to slow. Oh my gosh, dude. That's why. Bruh. Yeah, and simple little mistakes. Oh, great. Now something's not working. Time limit exceeded. It's definitely not because of that, but I don't know. Why am I getting an infinite while right now? I don't know why. I think I understand. What is going on here, dude? Bro, why am I getting an old pointer, bro? I don't know what's going on here. Okay, I think there's an issue here. Let's get rid of this for now. Okay. Let me create a note. We can paste our code in there. Okay, let's print the head. What the fuck? Found cycle in the list node. I think that's my issue. Okay. Last equal to fast on X, right? Okay. Then slow 2 is equal to slow. Start of the second half. Prev.next is equal to none. Going on. Okay. Cur 1 is equal to head. Cur 2 is equal to prev. While cur does not equal none. Then we want to do res is equal to max. Res cur dot one val plus cur 2 dot val. Cur 1 is equal to cur 1 dot next. Cur 2 is equal to cur 2 dot next. We return res. Jeez. Oh my gosh, bro. Okay, there we go. Alright, we'll submit that. So that's the way we do it. I'm going to call the video there because my friend's about to be here, but I appreciate you guys watching. I'm happy we could kind of sneak in a little bit of time for that. So I'll talk to you guys later. See you later.